1.7 is the last section that we'll cover in chapter 1, and that is working with inequalities. And we'll just work with inequalities in one variable, so graph them on a number line. So we are going to look at, for our objectives today, solutions of inequalities. And we solve inequalities the exact same way as an equation, but we do have two times where we have to flip our sign around, and we will talk about those. Use properties of inequalities to create equivalent inequalities, solve linear inequalities in one variable. We're going to work with the absolute value of inequalities, and we worked with the absolute value in the last section. And then use inequalities to model and solve real life problems. Again, those are your applications. So here's just a quick recap review of your inequality signs. So we've got our less than, greater than, and then less than or equal to, greater than or equal to, and then also the not equal to is an inequality sign as well. We just don't use it as often. So as an introduction here, we're going to review the graphing. And the graph, if you read through what's written there, the set of all points on the real number line that represents the solution set is the graph, because inequalities will have more than one solution, right? There's an infinite number of values that are greater than 1, right? It's not just x equals 1, it's any number greater than 1. So when we do our graphing, we could have two different types of graphs. We could have bounded, like they are here, and that's where you're given like a beginning and an end. And on all of these, we're given a beginning and an end. So they begin on this side at the A value and they end at the B value. And then the only difference is the sign that's in between. So notice if it is less than or equal to, we're going to use a bracket. If it has the equal to sign, we're going to use the bracket. If it does not have the equal to sign, we use a parenthesis. So it's kind of like open and closed circle, like it talks over here. The closed circle would be a solid bracket. So that's how the notation is over here as well. And then if you were to think like open circle, that would be your parentheses. And you could have one of each. So on the next one, we have a closed on one end and then an open on the other end. And then it can also be vice versa. It could start as an open and end as a close. So just pay attention to if it's equal to or not equal to. And we'll look at examples of all of these, of course, as well. And then here's your unbounded, where you just have one, think about it as one situation you have to deal with, one value you're focused on instead of two. So here we have x is greater than or equal to a. Okay, so we have the bracket because it's equal to, and then it just goes on forever with that arrow. So please make sure you include arrows. And then the notation for that, and this is called set notation. Set notation is we have the bracket and then it goes on forever. So we call that infinity. And then because infinity doesn't have an end, it'd be like an open circle. So we'd put a parenthesis. So infinity always gets parentheses there. So you can look through the rest of those and see all of the patterns that arise. So now let's go ahead and actually look at a couple. So we're going to write an inequality to represent each interval and then state whether the interval is bounded or unbounded. And we're going to graph these just to get some of that review in. So what this first interval says is we have -3. And because it's a parenthesis, that's just going to be less than x. But then we have a bracket, so that's less than or equal to our last number 5. And what this means is that x is between -3 and 5. It cannot equal -3, but it could equal 5. So when you're writing these, your inequality signs will always be the less than. You just have to decide if it's less than or equal to. And the reason for that is if you pick these apart, like if I only wrote this as -3 is less than x, I could flip this around so that's x is greater than -3, which is what we want, right? We want it to be greater than -3, but less than 5. But when I write it as one inequality like this, Instead of saying x is greater than -3, we flip that around so then it reads as -3 is less than x. So that's, we're always going to use the less than signs on these. All right, so let's graph this. What would this look like on a number line? So I know we'd have to go from -3, -2, -1, 0, 3, 4, 5. So maybe I label every third. So we are going to have then, if on the -3, it is just less than, and over here we can see it's a parenthesis. So we're going to put a parenthesis on -3. We're going to put a bracket on 5. So make sure I can tell the difference, please, between your parentheses and your brackets, and then everything in between gets filled in. So there's the graph of that one. And this one would be bounded because it has 2 endpoints. There's no infinity. It's only unbounded if it goes to infinity. Like our next one. So our next one is unbounded. And if we write this out then, all this is saying is, and I'm going to write it out like we did to begin with. So this would be -3 is less than x is less than infinity. Now, because it's unbounded, because it goes to infinity, we don't need to include this infinity part. So we can just rewrite our -3 is less than x written with x first. So if we write that with x first, we flip that sign around. So it'd be greater than -3. So -3 is the bottom. It can go to infinity. So anything greater than -3 is our inequality. And then to graph that one, again, we have our -3. There's our 0, and then we can put some more points out here. And we have greater than -3. So parenthesis on -3, do a different color. Parenthesis on -3, and then everything. So when you color in, then please make sure you include an arrow. And that goes to infinity. All right, our next example does not have an infinity, so it is bounded between 0 and 2. So this is saying 0, it has a bracket, so less than or equal to x. Again, another bracket, less than or equal to 2. And if we graph this one, we're going to go between 0 and 2. We're going to have a bracket on each one, and we're going to shade in between. And letter D has 2 infinities, so anything with infinity is unbounded. But basically, this just says x can be any number that you want. So negative infinity is less than x is less than infinity. And then that's how we would leave it because we don't have any specific numbers to work with. And then if we graph this one, if you're not sure, if you're like, well, how would we graph this? We haven't talked about it. If you look up over here, here's the example of the graph. It's just the entire number line. So we can throw a few numbers on there and just make sure we have arrows in both directions. So on my number line, I could put a few numbers, 0. But when I graph it, I'm going to color in everything, and I'm just going to make sure I do an arrow to positive infinity and an arrow to negative infinity. So there's some graphing and your interval notation, bounded and unbounded, and that notation that we'll use with the parentheses and the brackets.